The actual MX+ automatically converts any SATA drive to eDrive or SED or FDE, alternatively Microsoft eDrive. And next page we're going to define what is the eDrive and what is Microsoft eDrive. An eDrive constitutes three major functions. The first one being transparent hardware encryptions. And the second is TCG OPAL 2.0. The third is IEEE 1667 firmware. So these two are done in firmware, whereas the first one is done in hardware. Now, a BitLocker managed eDrive is called Microsoft eDrive. So that BitLocker will be serving as an interface controlling an eDrive through TCG OPAL 2.0 and IEEE 1667 firmware or protocols. Remember, the IEEE 1667 is a transient device authentication protocol. It's operating based on transient devices. So the 1667 has been existing for some time. On any standard Windows system, there comes with a 1667 driver. So the TCG OPAL does not have to be recreated as a driver layer because TCG OPAL can be operating underneath the 1667 driver as a silo. So that when you open up Microsoft Explorer architecture, you can tell that when this eDrive is operating, the TCG OPAL 2.0 is actually appeared as a silo under 1667 tree. So it's being controlled by 1667 firmware, but it's its separate silo. An eDrive can be internally a booting drive or a data drive. Configuration of a booting drive is a lot more complicated than a simple configuration of a data drive. We're going to get into that a little bit in the next few slides. So alternatively, an eDrive can be a portable drive, such as USB 3.0 or 3.1. But this is very unique to the MX+. This does not apply to any standard eDrive you purchase off on the market today. You cannot put an eDrive into a regular USB encoder and make it a Microsoft BitLocker to work on it. You cannot. What is the OPAL 2.0? So if you figure the entire disk drive, including solid states, with LBA, which is a large block access, LBA, with one LBA being 512 bytes or 4K bytes for GPT. This entire LBA has different numbers, depends on drive's capacity. So that a bigger drive, such as 1 terabyte drive, has a bigger LBA numbers than a smaller drive, such as drive with 120 gigabyte or 500 gigabyte. So the OPAL operating on LBA, and the OPAL code, this one called global range, and that global range has one unique secret key operating based on AES algorithm to encrypt an entire global range. So that's basically a concept for full disk encryption, such that entire OPAL 2.0 is built upon SED or full disk encryption technologies. Because OPAL need to be communicating with lots of table settings, and those tables are in clear text. The table has to be encrypted, and the FDE technology provides that. Such that the entire LBA is called global range, secured by a key, and it's an authority. A user can be an authority to decide the LBA ranges for a particular user to use. For example, in this example, the LBA range 1 and range 2 they are being created. Again, as creation of the range will get a new key assigned, which again is the AES secret key. And this secret key is different from range 2 secret key. So that user 1 to user number 8 can possess with a different key to unlock the data. So the entire OPAL 2.0 technology is about creating a particular user's range based on an LBA, and then assign those LBA with a unique secret key for a user to operate and it's get down to a very detailed control of users' privilege through read and write, such that if I created a range 1, I can limit that range for the particular user 2, for example, to limit the users to the operation on read only on range 1. And then I can assign a different key with the same user to operating on range 2 as write only, or etc. I can create a read-write privilege. So the entire OPAL 2.0 authentication is a very, very well-defined authentication protocol that down to the storage class with the I/O rewrite privilege. It's a very powerful tool, very powerful formula. If it's understood correctly, people will get to appreciate OPAL 2.0 technology. It's built beyond the full disk encryptions. We're talking about authentication based on locking SP, that's what we call locking security provider, or admin SP, administration's security provider. This is a role-based authentications. So transparent encryptions, how is MX+ able to perform for this transparent encryption? The MX+ sit in between the actual SATA host adapter and the SATA device, so that MX+ actually equipped with two complete SATA protocol stacks, one being SATA device protocol stack communicating directly with the SATA host controller, the other being SATA host protocol stack communicating directly to a SATA device. And because the MX+ working on the SATA physical layer, it responds and regenerates all those signals as required by SATA specifications, such that when a command was issued by a SATA host controller, the actual responding back to the SATA host controller is actually a MX+ with its SATA device protocol stack. And then when the data was sent, such as if a SATA host controller issued a write command, the MX+ detects that command, understood that command. So it understood it and interpreted the command. So to determine if the data carried by the write command will require encryptions, the encryption data will be first blocked, pushed to the internal AES engine of the MX+. So that's first 128-bit of the data block will be encrypted by AES engine of the MX+. And the MX+ will put the data in the output buffer and then regenerate the same SATA host write command to write and encrypt the data to the SATA devices. And because both sides of the SATA interfaces meets critical SATA specification timing in terms of rising, falling edge timing, setup hold time, so that this device is transparent to the SATA host controller and the SATA device. The SATA host controller is not be able to see there is an MX existing, unless you want to tell the SATA host controller say there is MX in between. Likewise, the SATA device cannot see there is MX+ sitting in between, so that this is a transparent and invisible device. And that's the reason for the transparent for this encryption technology, and that's where Enova invented this back in the year 2000s, and that's when Seagate first knew us in 2002, and it took us 3.5 years to educate Seagate how to implement for this encryption correctly. So back in 2005, that is our first ASIC sitting on the Seagate's drive. That's what I call 2.5 inches momentous for this encryption drive. The MX+ features. So why would an MX+ automatically converts any SATA drive to eDrive? Because the MX+ is a FIPS 140-2 level 3 in process or candidate. And it's the SATA generation 2 and 3 single chip critical modules. Second, transparent for disk encryption or self-encrypting devices capability. And third, TCG OPAL 2.0 and for IEEE 1667 firmware. So that the MX+ is able to convert any SATA drive, regardless of its geometry or capacity, into an eDrive. And better yet, If you have a BitLocker, and you can use the BitLocker to control the eDrive, and that's why we call it Microsoft eDrive. So that BitLocker has an interface, as we talked about in the previous slide, to control the eDrive behavior through OPAL 2.0 and IEEE 16667. The eDrive solution will be benefit from its fifth certifications. There will be. It's coming. I'm not saying no, but it's coming. So able to utilize any SATA compliant drive with any capacity. That's huge. We talk about it. And enable disk drive cloning. That's another good part of utilizing the MX+ technology. And of course, data backup is made easy. So essentially, you can use the data backup image software to image the entire MX+ control eDrives. No problem. And the image portion still remains encrypted, so that there will be no chances for any clear text to lag behind on the drive unprotected. Inline 6 gigabit AES performance. So it's a firmware adjustable, ECP, or firmware selectable electronic code book, XTX with TWIC, or CBC with IV. The Microsoft eDrive benefits. Now again, it's an eDrive controlled by BitLocker. That's called Microsoft eDrive. Has several benefits. Better performance because hardware encryption make it. Strong security is a hardware encryption, so it doesn't interrupt CPU or memory. Ease of use, encryption automatically turns on, so you don't have to worry about when to turn it off or etc. Low cost of ownership, we talk about it because the BitLocker leverage the Active Directory services through MBAM, so that Microsoft has streamlined the BitLocker Active Directory services, monitoring management utility, and all the way up to the server. So the deployment by using BitLocker will be a lot more faster and painless. Additionally, it's trusted computing. So we are paving the way for the next 5 years, 5 to 10 years. Our mission, our aim is to cover the entire computing environment, including your server, your gateway, and your multiple MX+ endpoint computing devices to become a trusted network. All the trusting capability is viewed internally to the MX+. Potential applications. You have a new motherboard design or new embedded system design that has a SATA interface. You can populate the MX+ chip on one or multiple SATA host controller port to make that port dedicated for Microsoft eDrives if you have a BitLocker. Or if you do not have a BitLocker, such as Macintosh or Linux, they don't come with BitLocker, we can remove the IEEE 16667 and make it OPAL 2.0 compliant drive. And in that case, Enova will produce you with the OPAL 2.0 management software for you to manage the OPAL drive. And that's for Macintosh, for Linux. Or if you don't like OPAL at all, simply because OPAL is way too complicated, you can just choose the FDE or SCD capability. And the second possible application is a retrofit. So your existing desktop can be converted into a Microsoft eDrive using BitLocker and serving as a booting or data drives, or other applications or other operating systems such as Macintosh or Linux. You can do an OPAL drive only or for this encryption drive, as simple as that. And there's a retrofit kit right here that will show you can mount a standard 2.5-inch drive or SSD with the right mounting kit to mount into a standard 5.25 bay of your desktop computer to make that desktop computer secure by either OPAL 2.0 or by eDrive, or better yet, if you have Microsoft BitLocker, turn that as a Microsoft eDrive. And this is MX+ was designed originally to secure data at rest, meaning data sitting on the drive. That's called data at rest. But MX+ is now advanced itself to encrypt data in motion, so that we'll be able to utilize the latest USB 3.0 and 3.1 technologies, and we'll be able to provide application software based on Windows or Macintosh operating systems, and then that would allow the user to select a particular file or folder to encrypt before the files is sent to the cloud storage, such as Google Drive or SkyDrive or Dropbox, for examples, so that we secure your entire cloud applications. And with that bandwidth encryption capability, we can even encrypt the entire VMware image. We can even encrypt the entire VMware image before the VMware image is sent to the cloud for operations. The next application, and that's for a portable drive. We'll be able to utilize the latest 3.1 USB 3.1 to SATA technology to make it with a MX+eDrive if you have a BitLocker, or it's a TCG OPAL compliant drive, and Enova will be happy to provide with the management software to manage the OPAL 2.0. So the differences between Windows and non-Windows OS is the BitLocker. In Windows 8.1 Professional or Windows 10 Professional and Enterprise versions, it comes automatically free BitLocker version for you to deploy. So that BitLocker will be serving as a management interfaces to manage all the security policies for MBAN and for actually directory services. For non-Windows, it's going to be OPAL only, or it's going to be based on for this encryption or a self-encrypting device. So this is comparison table. The most significant one is here the MX+ with the AES CPC XTX ECD 256-bit encryption real time. And there are other brand name eDrives such as the Micron 500, Seagate 500, and Samsung A50. And those are being compared right here. Or compared with others SED devices or other controller that has client with the internal AES block. You can see there are lots of nodes right here. But actually, if you compare with all the important features right here, you can tell the MX+ is much superior than current eDrive that you can find in the market. Especially important is the FIPS 140-2 level 3 and supporting any capacity of the drive and cloning and data backup for both booting drive and the data drives. Those are considered three most important features. This is the digital signature for trust relationship and the role-based identity-based authentication capability are also supported by the MX+, where you see role-based only over branded eDrives. So this is a benchmark. You can tell how fast the MX+ is performing. Anything 500, you'll be so happy. That shows that encryption, because there's a chip operating in between, so theoretically it's supposed to degrade a little bit performance, which is true, as there will be legacy. But legacy under the entire system performance benchmarking, you don't see much differences. And the better yet, the MX+ give you all the complete secure data protections. The system configurations, you need to have an MX+, and you need to have a BitLocker if you want to have a BitLocker eDrive or Microsoft eDrives. That's for the current, if you don't want to convert any standard SATA drive. Or you have a motherboard and system manufacturer, you simply populate a MX+ into any host controller port, as I said before. Or when peripheral manufacturer, you just make a small add-on port that contains the MX+ to retrofit the systems. So the features, I'll just repeat that. MX+ real-time transparent encryptions, has OPAL 2.0, IEEE 16667, capable of converting any standard SATA drive into an eDrive. If you have a BitLocker, you can control the eDrive with a BitLocker called Microsoft eDrive with inline speed. Able to convert any standard SATA drive regardless of geometry, or for this encryption at inline 6 gigabit per second speed. Now, let's talk about system requirement. This is important. This is important to understand. For Microsoft eDrives, there are system requirements for booting drive and for data drives. So for the booting drive, eDrive as a boot drive, the drive must be in an uninitialized state and the drive must be securely inactive. The most important part is here. You must have a UEFI 2.3.1 BIOS with this security protocol enabled, that's called EFI, Storage Security Command Protocol enabled. Some motherboards today has this BIOS, but with this shorter, this protocol is not defined. Some are. So it's important for the customer to verify with their motherboard supplier or system supplier that they have a correct BIOS version and they have this security protocol defined and executed. Now, the UEFI BIOS need to have a CSM, that's called Compatibility Support Module, disabled. And the UEFI BIOS need to be always booting from. It's boot natively from the UEFI. You cannot boot from the external drive. You cannot. You cannot boot from the CD-ROM. No, you cannot. You have to boot natively from the UEFI BIOS in order to be able to set up the eDrive as a boot drive. For the data drive, it will be a more simpler requirement. For the data drive, it's just an uninitialized state or a security inactive state, and that's it. You do not have that requirement of it being UEFI and the security protocol defined. You don't have those requirements above. So that you set up an eDrive as a data drive is now more simpler missions. But a lot of people want to have the booting drive encrypted too. So a lot of people, they want to use the eDrive as a boot drive. So these are our patents. Our patents cover United States, Canada, Taiwan, China, Korea, and Japan. They are all being filed within between year 2000 and 2005. So the patents are pretty young age, and those are patents that are being issued to Enova, covering the entire architecture of the footless encryption technology. This is our brief history about Enova technology. Starting founded as the year 2000, and then in the year 2002 we introduced the first XWO real-time encryption chip. I believe that it's in 2004 that I met with Asher. So we had that time as actual XO, and the next year we integrate our CO chip into it to make a Seagate for this encryption drive as 2.5-inch momentums. So in 2007 we introduced the first MX, which is the SATA to SATA generation 1.5 gigabit per second speed. This MX. As of today, we're still selling MX, believe it or not. A lot of people, they love MX. It's been produced, well tested, and well rounded. So there's no problem with it. And then we have Enigma 1 and 2. We have a DX, which is our USB 2.0 OTG real-time encryption chip. Based on this chip, we make Enigma 1 and Enigma 2 as Emperor solutions. Today, we'll be migrating to Enigma 3.1 solutions, utilizing the latest USB 3.1 technology. We'll be doing the Secure NAS T2, which we're not going to cover within this presentation because it's a NAS product that requires a lot more detailed and thorough discussions. Thank you very much. You have any questions?
Thank you very much.